Hello and welcome back to Music and Technology. In today's lesson, we're going to be talking about signals and your digital audio workstation, also known as your DAW, D-A-W. As always, this presentation can be found on our Google Classroom in the form of slides if you wish to go through it on your own, at your own tempo. As well, don't forget to answer this week's discussion question based on this lesson. All right, let's begin. The interface. So what is an interface? Well, you need a certain way for your audio to get in and out of your computer, and your audio interface is that device. There are many different types of audio interfaces out there from a number of different companies. The one that you see in the background, and actually the one that I use at home here, is the Focusrite Scarlett Studio interface and microphone. And the interface, okay, this specific one gives different inputs and outputs. The one that I use has 2 inputs and 2 outputs, but there are different ones and sizes of interfaces out there. For example, the one in the background here that you see, okay, has 4 inputs and outputs, each with its own gain level and pad. Now remember, inputs that are coming into these interfaces and going out use different types of cables. Typically, coming in, you would use a 1/4 inch cable or a TRS cable to balance out the sound. You may also input MIDI inputs and outputs on the back, especially if you have old school synthesizers that don't have the USB connector. You can connect them through your interface using a TS cable, a 1/4 inch cable, or even an XLR cable if you have a microphone. These interfaces nowadays connect to your computer via a FireWire connection or USB connection. Now, the FireWire works better with larger number of audio streams at once. For example, in our school, we have a D-Snake box that has a whole bunch of connections, that all those connections from different microphones feed all the way down into one specific FireWire cable that runs from the studio into the computer itself. It's very, very handy. And what the interface does is inside the audio interface itself, there's this very tiny computer chip which we call an analog to digital converter. It converts the analog signal that is coming into the interface as a voltage, and it's pumping out a digital signal in ones and zeros so that your computer can read it and understand it. So, an interface, the type of interface that you use, that you purchase, that you use at the school, that you may use at home, okay, depends on the type of recording that you're doing. You need to understand how many inputs and outputs that you actually need. The larger interfaces do cost more than smaller interfaces, but you can get some very high-powered small interfaces such as the Focusrite Scarlett Studio or Scarlett Solo that I'm using here. Your inputs and outputs. So it all depends on what you're trying to record and how many things you're recording, right? The more microphones, the more instruments that you're trying to record at the same time, the more inputs and outputs that you'll need. Now, most have XLR inputs for a microphone, okay, as well as knobs, gain knobs, that are used to control this input and the level of input coming in. You want to make sure that the level of input coming in is about 3/4 turned. Okay, so if you're thinking about it in the face of a clock, right, you want to start at 0, okay, and you want to turn it all the way to the 3/4 mark, all the way around, okay? So that you have the appropriate amount of input coming in, the gain coming in, the levels are good, and the sound that you're going to record is good. If you go above or too much past that 3/4 mark, you're going to get some distortion and feedback. You're also going to find some switches on your audio interface. Typically, there will be a button or a switch for the 48 volt phantom power for your condenser microphones. Remember, condenser microphones require phantom power, which is usually set at 48 volts. Dynamic microphones, all you do is you plug and play. There's no need for power. There's also a pad, okay, a pad button that you can see. And this is to lower the value of the signal, right? If you click the pad, it'll actually compress the signal a little bit. And this is good for changing the level of the signal coming in. If you have your gain set, but you want to have a specific input or microphone or instrument coming in at a lower level, a lower volume, then you would hit the pad and it would compress it. And everything that does not have the pad pushed would be a little bit higher. You also have a headphone output, typically on the front or the back of your interface. The newer models have them on the front, making it very user-friendly for headphones. And you want to make sure that you have good quality headphones. Okay, and listening sound, right? When you're listening through, you want to make sure that it is of the best quality. So it's better to use the interface for your headphones. Sometimes you get an 8-inch headphone jack, and sometimes you'll get a 1/4 inch headphone jack. The 8-inch is the normal headphone jack. The 1/4 inch is the bigger studio type headphone jacks. But try to use your interface for that sound output towards your headphones. You'll get a better quality sound rather than plugging directly into your computer headphone jack for the sound. So, microphone connections and gain. So, to start off, you're obviously going to connect your microphone to the interface. And you want to make sure that you set the gain properly. Now, before you connect your microphone, okay, you want to make sure that everything is turned down, right? When you're connecting your microphone, to avoid creating any kind of sound or clicks or horrible feedback, you want to make sure that the gain or the volume level on your speakers and on your audio interface is turned down, so that when you plug in the microphone, you don't get any feedback, and you also don't get any clicks or pops through your speakers or your headphones when you plug it in, which is really handy. Now, here's the procedure for connecting a microphone. Okay, to disconnect, we're going to go over it quickly, but to disconnect is the same process. So, like I said, you're going to reduce your input gain all the way down to 0. Okay, the most important knob you are going to use to adjust while recording is this gain knob. The signal will then not go through the system, right? This is going to set the level that gets to the analog digital converter. Okay, you don't want to blow that converter and ruin your interface. Okay, you're going to make sure that your phantom power is turned off. Okay, so if you have a button or a switch on your audio interface, you want to make sure that that button is not pushed, and that when you plug your microphone in, you want to make sure that it has no power coming through it as soon as it's plugged in. You want to plug it in before turning on the phantom power. This will prevent any clicks or pops that could actually damage the very sensitive membranes within your condenser microphone. Okay, next, you're going to connect your microphone to your interface using an XLR cable. There are two ends to the XLR cable. Okay, the microphone, on the microphone itself, on the bottom of the microphone itself, it will always be the male end, the 3 prongs. Okay, and the interface will always have the female end. Okay, and so using your XLR cable, which has 2 ends, one a male, one a female, the female end of the XLR cable is going to attach to the microphone, and the male end of the XLR cable is going to attach to your audio interface. Next, you're going to turn on the phantom power. This is like turning on your microphone. You're going to set the input signal, which is the gain, the volume. Okay, you're going to set it to a level as to where you want it to be in your final recording. Okay, it's really good to set it to about 3/4 of the way around. You want a good signal, but you don't ever want to go over. So it's always a good thing to err on the side of the lower signal, lower gain first. You can always bring it up in the computer later. You don't want distortion, and this will happen. I guarantee you this will happen if your gain is above that maximum, above that 3/4. Okay, and you can turn the knob to manipulate the microphone preamp. On most interfaces, you'll see a color knob. Now, on the interface that I'm using, there's this ring of color around the gain knob. As I'm talking to you right now, that color ring is lighting up green. That means the signal is good and it's picking up the signal appropriately and the level is good. There's no distortion. If you get a yellow signal, that's okay, but that's your maximum. You don't want to go above yellow. And if you go above yellow, the new style of audio interfaces will give you a red ring around your gain knob, and that will tell you that the signal is too hot, coming in too strong, and you're going to get feedback and distortion. So it's important just to err on the side of keeping things a little lower, because you can always raise them later on, either in the computer or even on the interface itself. It's better to do it in the computer, but it can be done. So to disconnect, you're just going to go in the reverse order. Turn off your monitors, turn off your speakers, okay, and turn down your output volume before disconnecting. Then you're going to turn the mic gain all the way down. Then you're going to turn off the phantom power and then disconnect your microphone. You want to make sure to do it in this order. So turn down your speakers or off your speakers and turn down the volume. Then turn down the gain all the way. And then click off the phantom power, that 48 volts, and then disconnect your microphone. You don't want any clicks or pops. Okay. Like I said, inside of your audio interface is this tiny little computer chip. Okay, and it's an Arduino, and it is converting from the analog in signal to the digital output signal. So we have analog in, goes through the computer system, the Arduino board, and then out digitally to your computer. So in as a voltage, out as ones and zeros. Okay, we also call this sampling. Now, many of you have probably heard of sampling in terms of a rap artist going to the studio and sampling some tunes. Okay, it's very similar. The definition is very, very similar. But what it essentially means is you're taking a very small piece of audio and representing that rate of audio, the sampling frequency, into ones and zeros. Now, the frequency typically is 40,000 pieces of audio that comes into the board in analog per second, typically in the analog to digital converter. Okay. The computer can only understand binary data, ones and zeros. That's really important to know. But the sound coming in from your microphones and your instruments is in an analog signal, so it's a voltage. Because when I'm talking through this microphone, the microphone is picking up my voice, the sound pressures in the air, and is then converting that sound pressures into a voltage, which is traveling to my audio interface. That voltage, via this converter, is being transferred into a digital binary code for the computer to understand. And it's a very small piece of software or hardware, that goes into the interfaces that actually does this job. And it's pretty awesome. Okay, pickup connections. So there's a number of different things that we deal with when we talk about pickup connections. And those pickup connections are, there's different styles. Today we're going to talk about 5 different ways that you can have pickups in your, how you can set up your studio's sound to pick up the right amount of signals. So you are likely to record using an electric guitar or electric bass. Sometimes you might have an acoustic guitar that has a connection, a pickup, but typically it's an electric guitar or electric bass. Now, pickup is also an input transducer, right? And so it's coming out of the instrument into the pickup, okay? And then into the audio interface. It's an input transducer, but the levels and signals vary depending on the type of microphone you use. Okay, the output cable is always going to be a 1/4 inch or TS cable. Okay, that cable is going to go from your instrument to the audio interface. If you're using an instrument, it's always going to be a 1/4 inch or TS cable. Okay. The inputs on your instrument as well as the audio interface are designed directly for instruments. Okay, these are instrument inputs that have direct input or high Z input. That's what we call them, high Z inputs. The audio interface will tell you right on the interface if there's an instrument input. So you'll see under the input, the actual hole in the interface, it'll say for instrument or for microphone. Okay, remember, setting your levels for your instrument is very similar to setting the levels for your microphone. There is no phantom power necessary, but you want to make sure that the gain and the volume on the speakers is turned all the way down so you don't get any feedback, clicks and pops that are going to damage your speakers or your interface. Okay, then you can connect your guitar or bass to the interface and set the levels as we discussed. So pickup connections. Now there's always going to be delay. Okay, because that signal is going from the instrument through a cable into the interface, through the interface into your speakers or into your computer and then to your speakers. There's always going to be some delay in that sound. Okay, because the computer can only do one thing at a time, right? It's not live sound, it's got to travel and then out to your speakers and back to your ear. Now, if any of you are musicians or performers, you know that delay can hurt your performance, right? It's hard to get into the groove if you're playing along and you're hearing through the speakers the delay of when you hit the note and for when the sound comes out, right? There's always this delay, and so it's very hard to get into the groove. And so it's important to monitor the signal as you play, which essentially means to listen to your sound as you play. Many instrumentalists, many performers, as you'll see in rock concerts, they'll have speakers or monitors in front of them so that as they play, they can actually hear their sound live. It is best to monitor outside of your computer, okay, to use an amplifier so that you can hear the sound in the room as it is going into the computer. It makes it way much easier to perform because it actually reduces the delay quite significantly. There is a very, very split millisecond of delay still, but it does reduce it by considerably. So let's take a look at different type of pickup connection options. So here's your first option. You're going from your instrument directly to the audio interface using a 1/4 inch TS cable. Okay, so as you can see, we have our electric guitar, we have our 1/4 inch TS cable or our instrument cable. Okay, it's plugged directly from the guitar into the audio interface. We call this direct input. Okay, goes into the interface, out to your computer, then out to your speakers. The the second type of pickup configuration, okay, is where you connect your instrument via a 1/4 inch cable to a guitar or bass amp. Okay, now that bass amp or guitar amp is plugged into power, but there's no other cables coming out of there into any other thing. Okay, then you're going to connect a microphone using an XLR cable that will then connect to your audio interface. Okay, with the microphone picking up the sound from the amplifier. This is a very common way to record, and you get the sound of the amp as a benefit because you can hear what it sounds like live, and it actually reduces the delay quite a bit. The downside to this is that the microphone that's set up in front of your amp is also going to pick up the sounds of the room. And you may get some feedback with the microphone without direct recording. Okay, so this is your option number 2. Option number 3. So option 3, it's similar to option 2, but you take out the microphone. So you're going to connect your instrument via a 1/4 inch TS cable to your amp. There's going to be a line out. Okay, this line out is typically another 1/4 inch TS cable. That line out is going to go to your audio interface. Okay, it's really important because a lot of amps have 2 different line outs. There's a line out and then there's a speaker out. You do not want to connect this, your audio interface to the speaker out, okay, because it's going to give the levels set for the speaker out are really, really high. And you don't want to do that because you will most likely damage your speakers, and you could actually damage the converter that's inside the audio interface as well. Okay, so never hook your gear to the speaker out, as the output signal is very high and will most likely damage your equipment. This is a typical pickup configuration. It requires less cords and no microphone, which is nice. And you're still able to hear yourself live. So there's the half a millisecond delay from the signal going from your instrument through this first 1/4 inch cable, but that's it. Now, the next one that we're going to look at, the option number 4, okay, utilizes a direct box if your amplifier does not have a line out. The newer amps do, but some older amps or amps that people have had for a long time, or perhaps an amp that you pick up at a garage sale, it might not have a line out that can go directly to your audio interface. So using a direct box can actually help with that process. Now, at the school, we do have 2 direct boxes. They're these tiny little purple and black boxes that help reduce cable noise and increase the balance of the sound traveling through the cables. It also allows long range cables to be hooked up. So if you're on a stage and your audio engineer is way at the back of the house, you can actually hook up your instrument to the direct box. Then the direct box can hook up via a very long XLR cable all the way to the studio. Now with this configuration, it allows you to go from 1/4 inch to XLR, and it keeps the distance of cables shorter, okay? Which reduces the kind of the weird noises that you get with longer cables, and the delay is way, way reduced. Now remember, when disconnecting your gear, you're going to turn the input gain down and turn your speakers down before disconnecting any instrument, because you don't want any clicks or pops to come through. All right, so here's option number 4. You're going to hook up your instrument to the direct box using a 1/4 inch TS cable. You're going to then hook up your amp with another 1/4 inch cable to the direct box so that you can hear yourself live. And then from the direct box, you're going to hook up to your audio interface using an XLR cable. This will reduce noise, it will increase sound balance, and it will allow you, and it will decrease the delay, which allows you, using an amp, to actually hear yourself play live with almost no delay. The last option is called pickup option number 5. Okay, it's very similar to pickup option number 4. The only difference here is that we are using a microphone. Now, if you have all this equipment, this is a very, very good way to record, because you can get two different sounds with almost no delay, and it's really, really handy. This is also a really good way to perform live if you're using an audio interface to perform live. But you have to remember that by connecting your microphone to your audio interface, yes, the microphone is going to pick up the sounds from the XLR cable, but it's also going to pick up the sounds from all around the room. Our last thing that we're going to talk about is our flying around the room here, our DAW, our digital audio workstation. Now, this is your central hub of music production. Okay, our school has Logic Pro 10, which is our main digital audio workstation. If you have a Microsoft computer, Audacity is the number 1 free DAW system. And if you have a Macintosh, you get GarageBand as your digital audio workstation. It comes free with all Mac products. Now, these software packages allow you to mix, master, and manipulate the sound. And all of these programs can be used for composing, producing, recording, mixing, and editing your audio and MIDI signals. It's also really important to get a good set of speakers, okay, or monitors. I call them monitors. You want to get some that are designed specifically for being used in a studio situation. And there are some really good studio monitors or speakers out there. And they're usually powered speakers, so they require some kind of power that give you this awesome transparent type sound, so that anything you do, you can actually hear through your speakers. And it's really cool because you can hook up your speakers to your audio interface and not have to worry about the garbage speakers that are built directly into your computer. That's all I have for today, folks. Thank you so much. I hope everybody has a wonderful week ahead. Don't forget to answer the discussion questions for this week, and we'll chat with you soon. Bye for now.